Good afternoon, everybody. Today I discuss the numerical problem on effective stress, total stress, and neutral stress. In previous video, we discussed all the theory parts, and now our main purpose is to determine the total stress, effective stress, and neutral stress in numerically. Okay. Now these all problems on this chapter is very important for your GATE and IES conventional also. Okay. That's why in my notes I already covered different numerical. Just I pick this numerical for your better understanding. Okay. Now this is a strata, soil profile strata, clay layer underlain by sand, means the sand is upper part and the clay is lower part. Clay is lower part and sand is the upper part, and our main task is to determine effective stress, pore water stress, and total stress in A plane, BB plane, CC plane, DD plane, and EE plane. And then we draw the diagram of three stresses. Now there is a different layer, sand and clay, means its property will be different. In our sand layer there is Z 2.65, void ratio E 0.85, and the effective diameter D10 equals to 0.14. Similarly, for clay layer, water content 22% and the specific gravity 2.65. Now there is a tendency of capillary rise because D10 has been given. That's why first we determine the height of the capillary. We know the height of the capillary, we can easily find out, that is HC equals to C by E D10. C in our problem, that is 0.5, E void ratio 0.85, and D10 that is 0.14, means we can easily find out the capillary height is 0.42 meter, means this distance is 0.42, and our numerical, that is the water table, is 6 meter from the GL, ground level, means this height is 6 meter, and the total thickness of sand layer is 8 meter, means this layer is 2 meter, and the height of dry sand layer is that is 6 minus 0.42, that is 5.58 meter. Now we find out the unit weight of the dry unit weight of the sand, saturated unit weight of the sand, and also the saturated unit weight of the clay, because the clay layer is fully saturated, water table here, clay is fully saturated, and above BB line the sand layer is dry because capillary up to BB line. For sand, gamma sand equals to, we know, G plus E by 1 plus E gamma W. Put the value G 2.65, E 0.85 plus 0.85, and gamma W is 1 in ton per meter square, unit weight of the water. That's why this value is 1.89, I think 1.89 ton per meter square. You solve a numerical by your own, okay, because maybe my calculation will be wrong, okay. You solve by your own, okay. And gamma D means dry unit weight for sand is G gamma W by 1 plus E, and that is 2.65 in sand into 1 by 1 plus 0.85, and the value is 1.43. Means gamma D dry unit weight of the sand is 1.43, and the saturated, this layer also sand, and the saturated unit weight for sand is 1.89. Sand is saturated unit weight 1.89 ton per meter square. Now clay. For clay layer, the saturated unit weight for clay, that we know G plus E by 1 plus E gamma W. Now when we find out the value of saturated unit weight, E has not given. Now we find out the E from our previous relationship. We know that E equals to Wg by S. W known, G 2.75, and S is the saturation. The clay is fully saturated, that's why S 100%, S means 1. Put the value, and that is 2.75. E equals to 0.605, 2.65 plus 0.605 by 1 plus 0.605 into 1, and the value is suppose 2.09 ton per meter square. Means the saturated unit weight of clay means gamma sat for clay is 2.09 ton per meter square. Now all the unit weight here find out. Now our main part, step 2, to find out the total, effective and neutral stress. Okay. Now I omit this part. Now first, total stress. For AA plane. At A plane, there is no extra surcharge load or no other load. That will be that means there is no stress. Means total stress for A equals to 0. Now BB plane. At BB plane, this soil is dry, this sand is dry. That's why gamma that is 1.43 into 5.58, because this distance is 5.58, and this value is 7.98 ton per meter square. Okay. Now at point CC, total stress will be calculate from the top, that is 1.43 into 5.58 plus this soil is saturated, this sand is saturated, because due to capillary action, plus saturated unit weight of sand, that is 1.89 into this height is 0.42 and sigma C equals to 8.77 ton per meter square. Now at DD, sigma D equals to, from the top, 1.43 into 5.58 plus 0.42 into 1.89 plus 2 into saturated unit weight of the sand, because water table here and this sand will be saturated, means we can consider the saturated unit weight of the sand, that is 1.89, and the value is 12.55 ton per meter square. Now at E plane, it will be 1.43 into 5.58 plus 0.42 into 1.89 plus 2 into 1.89 plus 6 into unit weight, saturated unit weight of clay, that is 6 into 2.09, and the value is 25.09 ton per meter square. Now we calculate the unit weight of a total stress of AA plane, BB plane, CC plane, DD plane and E plane. Now we calculate the second part, that is neutral stress. Neutral stress. At A, neutral stress, there is no water effect, that is 0, because neutral stress means the stress due to water, UA equals to 0. Now at BB plane, UB equals to minus of 0.42 into unit weight of water, because at BB plane there is a neutral stress due to capillary rise, and that is gamma W into H. H is 0.42 and gamma W is 1 unit weight of water, and this minus represent the capillary action, because the water moves upward, and that's why this is the minus, and that is minus 0.42. Now at CC, here, from here water table start, मतलब CC से वाटर टेबल स्टेबल, इस प्लेट का नीचे से ही वाटर के वजह से स्ट्रेस डेवलप करेगा, इसलिए एट CC प्लेन देयर इज नो इफेक्ट ऑफ वाटर टेबल, यहाँ पे वाटर के वजह से कोई स्ट्रेस नहीं है, इसलिए एट CC प्लेन UC इक्वल्स टू 0. नाउ एट DD प्लेन UD equals to 2 into unit weight of water, because water table here gamma W is 1 and height up to DD is 2, that is 2 into 1, 2 ton per meter square. Now at E say the height of the water table into gamma W, because neutral stress मतलब क्या है, वाटर के स्ट्रेस के वजह से वाटर का हाइट कितना है 6 plus 2 8 और यूनिट वेट कितना है 1, that is 8 into 1 means 8 ton per meter square. Now we easily find out the neutral stress. Now our third part is to determine the effective stress. Now we know effective stress equal to total stress minus pore water stress. Now at A plane, at A total stress 0 and neutral stress 0, means 0 minus 0 equals to 0. At BB plane, at BB total stress, that is 7.98, and neutral stress minus of minus 0.42, means it will be 0.48. Okay, 8.40. Now at CC, effective stress at CC, total stress at CC, is 8.77, and the effective neutral stress at CC 0, means it will be 8.77 ton per meter square. Now at DD, total stress 12.55 minus neutral stress at DD means 2 into 1, that is 2, means 10.55 ton per meter square. Now at EE, effective stress, total stress at EE, that is 12.09, and pore water stress, that is at E, means 2 plus 6, 8 into 1, means 8, that is 17.09 ton per meter square. Now we find out total stress, neutral stress, effective stress in EA plane, BB plane, CC plane, DD plane and EE plane. Now we draw a diagram for total stress, for effective stress and for neutral stress. Now for neutral stress, this is A, BA, C, D, E. Neutral stress at A 0, at B minus 0.42 minus 0.42, at C at B, that is minus 0.42, and here 0, here 0, here 0, stress from start from here, that is 0.42, at C, that is 0, at D, that is 2, ton per meter square, and E, that is 8. This diagram for neutral stress. Okay, first diagram complete. Now second diagram. Now total stress at A, that is 0. For B, that is I think 7.9, 7.98. At C, that is 8.77. At D, that is 12.55. At E, that is 25.09. Sorry. $25.09. This diagram for total stress complete. Now our third part is effective